Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. Here, me and my friends will explain about sensor application for water bottling system. To be begin, water filling machines are tools used to dispense liquid or powder into bottles. The bottle filling machines are the main machine tools for the packaging process in numerous sectors, including pharmaceutical, chemical, agricultural, and food. The manual technique of bottle filling cannot be employed in modern enterprise with bulk filling requirements, since the procedure might waste substantial time and may result spillage or wastage of the items. Then, this machine is save cost, time, and consistency operation compared to manual filling. After that, the design of schematic diagram of the bottle filling machines and process by each station will be explained. So from this study, we can know how the sensor used to enable the system become automatic and predict the possible error that may occur during production.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nukla binti Kamal Zaman. My student ID is TB19108, and today I would like to introduce to you the schematic diagram of the bottle filling machine. So as you can see from this slide here, this is the schematic diagram of the bottle filling machine, which is consists of 7 stage, which is the first one is heating stage, mixing stage, filling stage, weighing stage, putting cap stage, checking stage, and production stage. So at this schematic diagram, the water will flow into the mixer, as well as the heating liquid will also flow into the mixer. So mixer will mix the water and the heating liquid to produce a liquid mixture. At all of these 3 tanks, each of the tank will has one sensor. After that, at the fitting value, the valve solenoid will open, so the liquid mixture will flow into the filling stage. In the meantime, the empty bottle water will move from the receiver until the production stage. As you can see here, we have 2 sensors here at the beginning, which is act as a transmitter, and at the end of the conveyor we have a transmitter. This is for the safety purpose of the production. So next, the water bottle will move to the weighing station, which is at this point. The sensor will sense the weight of the water bottle. If the water bottle doesn't meet the certain value set, so the water bottle will go back to the filling stage to fill until it is meet into the certain value set. After that, the fill bottle will go to the cap stage. At this stage, the bottle will be capped and then move to the next stage, which is at the cap fixer. At this point, the cap will be tightened up and then move to the checking station. At the checking station, there is a sensor that will check whether the bottle meet the certain criteria set. For example, like if the bottle is broken because of the conveyor is too slow or too fast, so the water will be eject because the water bottle is broken. If not, if the water bottle is in the perfect condition, meet the certain set condition, so the water bottle will move to the final production. As you can see here, we have a control unit here. The control unit function is to control all the mechanism used in this machine and also the sensor that are used in this machine. So control unit here act as a user manual control machine controller. As you can see at the bottom here, we have a transfer unit section, which has a conveyor controller and also have a driver motor. This is for the conveyor to move from the beginning until the end of the production. So next is how each of the stage work. The first one, we will go with the heating stage. At this stage, the sensor that are used is capacitive proximity sensor. These sensors are used to detect the liquid, powder, and also the granular items in the addition metallic ones. So the work of the sensor recognized by the changes of capacitance. It generates an electrostatic field when both plate capacitance rise as a conductor or non-conductive object get closer to the sensing area. So from this, it will cause the oscillator amplitude to gain. In another word, sensor output triggered by the resulting amplitude gain. So next is mixing stage. At this stage, the sensors that are used are ultrasonic proximity sensor. The sensor uses high-frequency ultrasonic emission, and it detects the presence of the unused steam in the liquid. For example, like solid or liquid or granular, and also the granular things. This sensor converts electrical energy when the sound of the transducer sends forth sound wave. The item causing sonic wave to reflect. The wave that bounces off is then returned to the sensor, and the amount of the time took for the sound wave to transmit and receive is utilized by the distance and the proximity. Next, we will move to the failing stage. At this stage, the sensors that are used are cylinder and magnetic sensor. The sensors are used to utilize and provide position feedback to control the system. It determines the linear position of the piston, and the function of the sensor are signaling on or off depending on how close it is to the magnet. So the work of this sensor is the magnetic sensor consists of a wire coil around a permanent magnet. So furthest object approaching the sensor changing the magnetic flux through the coil, generating a voltage at the coil terminal. Next is at the weighing stage. For this stage, we use a weight sensor. So weight sensors are used to transform force or pressure into electrical output. The load cell detects the changes in total weight as the machine fills the bottle. So it detects or scale weight of the bottle. The work of this sensor is when the filling procedure automatically ends when they predetermine the overall weight in a tank and the bottle is transported to the capping station. As for the system, in this stage, it detects or scale the volume of the bottle. If it is not enough, it will turn back to the filling stage.
Torque sensor. Amplifier sensor is used to adjusting the torque. Rotating torque sensor is used to determine how much electric power to push and tighten the cap. The automated packing lines include these capers. Check capers are accessories that may be mounted to capers to help them grasp caps. Check caper can tighten caps that have already been applied to the container using the script bottle. The selection of the proper caper type and size is crucial for the entire lead of the capping procedure. Next is checking stage. For this stage is use proximity sensor. The sensor is used to detect that the bottle is there or not. This is because to keep the bottle move one by one on the conveyor. In contrast to sensor like limit switches, this detect item by physically coming into touch with them. A proximity sensor does non-contact detections. Proximity sensor turn movement or item presence information into an electrical signal. For the production stage, there is a transmitter and receiver sensor are used here. If the bottle is moved toward the transmitter and the receiver sensor, the production stage is full of the other bottle, the sensor will detect it and the conveyor will stop. In conveyor, the speed switch sensor are used to generate warning when conveyor belt fail, slide or stop moving abruptly. Ferrous metal proximity sensor are used to examine aluminum assemblies for steel components. They are also used in manufacturing lines to monitor the location, spacing, and alignment of moving components. The transfer cover usually closed down as safety precaution. A limit switch will be closed when the transfer cover is closed down. In the capping stage, the expected error might be occur because of inconsistent capping. The torque error introduced by the excessive clamping can be easily evaluated by rotating a loose cap on the bottle thread. A clamping pressure-sensitive bottle will produce noticeably higher torque compared to the torque on a bottle that is clamped with optimizing pressure. In a conveyor belt, error happens because of the speed of conveyor belt inconsistent. When conveyor belt speed is too slow, bottle gets stuck at the first stopper. The flow is disrupted and the mover damages them. When the conveyor belt speed is too fast, bottles lose their balance and fall when they are blocked by a stopper, and if they continue, they are damaged by the mover. By adjusting the speed so that it's neither too fast or not too sluggish, the controller position behind the transfer cover panel ensures that the speed is optimal when water bottling system is running and the transfer cover lift up. The limit switch will be open and will trigger the alarm. Next is for checking stage. The expected error is inconsistent of conveyor move. If the conveyor moving too slow, the bottle will still reach the space between those two stoppers, but occasionally it will get clamped by first stopper cause moving too slow. And lastly is production stage. The error is flow finishing product. The finished product could include flaw and error was possibly that the sensor is failed to identify which is the flaw accurately and spread it from the good final product.
Next is expected error for the system. At the heating stage, the expected error is a wiring error. If the heater does not operate in auto mode, the cause of the incorrect temperature control unit wiring is unclear, and it causing the heater to fail to work when it's supposed to. Next is at the mixing stage. The mixing stage, we have error in reading in ultrasonic sensor, which is indicate an incorrect reading. So to prevent this from happen, we have to make sure the water level is not too high, because if the level is greater than the blue strip towards the top of the tank, the sensor will provide an error result. So next at the filling stage. At the filling stage, we have inaccurate filling level and timing. The transferring mechanism metal climb into a bottle and damage it. The next is at the wagging stage. At the wagging stage, the error occurs when the stability of the bottle is not stable enough. Error in stability of the bottle occur when the wave sensor detects the volume of the liquid in the bottle is not enough.
In the capping stage, the expected error might be occur because of inconsistent capping. The torque error introduced by the excessive clamping can be easily evaluated by rotating a loose cap on the bottle thread. A clamping pressure-sensitive bottle will produce noticeably higher torque compared to the torque on a bottle that is clamped with optimizing pressure. In a conveyor belt, error happens because of the speed of conveyor belt inconsistent. When conveyor belt speed is too slow, bottle gets stuck at the first stopper. The flow is disrupted and the mover damages them. When the conveyor belt speed is too fast, bottles lose their balance and fall when they are blocked by a stopper, and if they continue, they are damaged by the mover. By adjusting the speed so that it's neither too fast or not too sluggish, the controller position behind the transfer cover panel ensures that the speed is optimal when water bottling system is running and the transfer cover lift up. The limit switch will be open and will trigger the alarm. Next is for checking stage. The expected error is inconsistent of conveyor move. If the conveyor moving too slow, the bottle will still reach the space between those two stoppers, but occasionally it will get clamped by first stopper cause moving too slow. And lastly is production stage. The error is flaw finishing product. The finished product could include flaw and error was possibly that the sensor is failed to identify which is the flaw accurately and spread it from the good final product.
So, as for the conclusion, from this study, we gain knowledge on the work of the bottle machine system. The use of the water bottle plastic system is well known in the big industry production. The system is easy, smart, and low cost. The use of the sensor in a part of the water bottle machine play a big role in the system to work. So we also study the characteristic of the sensor to work for each part of the water bottle machine to system. Each sensor is described well with the expected error for each part. Last but not least, we also able to design the schematic diagram of the water bottle machine based on our understanding of the system flow. So that all from us. Thank you.